Everyone, I'm Zhentao. I'm Zhentao from University of Macau. I'm here to share our review on non-destructive testing method for detecting tile defect on building exteriors. So the presentation includes 6 parts. Let me get started in the introduction. Tiles are widely used for building exteriors because of the waterproofing, thermal insulation, and aesthetic functions. But tile defect occur much earlier than the building design duration. With the fast development of non-destructive testing method, it provides an accurate method to detect the tile defect on building exteriors. But the question is, we lack clear taxonomy of tile defect and corresponding non-destructive testing method for detection, so resulting in limited understanding of how different NDT methods could be effectively implemented and integrated to detect multiple tile defects at the same time. So our aim is to review the existing literature review on the technology for non-destructive testing detection on tile defect on building exteriors. There are 3 research objectives. The first is to clarify the types, cause, and impact of the tile defect on the building exteriors. And the second objective is to compare the application scenarios, advantages, and limitations of different NDT methods. And the third objective is to propose a framework to effectively implement and integrate NDT method to detect the multiple tile defect at the same time. And methodologically, research Web of Science and Scopus for peer-reviewed journal or conference paper in English up to April 2025 from 486 records. After screening and cross-referencing, 25 in total 25 research have led. And here's the taxonomy of tile defect on building exteriors. The first category of tile defect is surface defect, including dirt, glass detachment, crater, and efflorescence, as shown on the left. And the important cause of the surface defect includes environmental factors like pollutant and the material itself, like salt in the substrate, in tile firing process when manufacturing the tiles, and then the poorly designed joint and localized moisture expansion. And the key impact of surface defect is mainly aesthetic. And the second category of tile defect is fracture-related defect, which refers to the linear separation, including crack and fissure. And crack refers to the linear separation that larger than 5 millimeters, and fissures wide of linear separation is less than 5 millimeters. And the important cause of fracture-related defects include inadequate design, structural overloading, thermal inspection, and environmental factors. And the key impact of fracture-related defect has 3 parts. The first is to compromise aesthetic integrated, and secondly, the rainwater would infiltrate through the fracture-related defect and causing dampness in the substrate, and then degrade the bonding quality between the tiles and substrate. And the third category of tile defect is adhesion failures, which refers to the poor quality between tiles and substrate, including debonding and detachment. We define debonding as the incomplete separation between tiles and separation, while detachment refers to the complete separation and subsequently fall off. And notably, debonding, the appearance of debonding is the same as the intact tiles. So the important cause of adhesion failure include improper installation, climate-related corrosion, aging of the tile system, and water infiltration. And the key impact of Adhesion failures include aesthetic degradation and reduced durability of the facade tiles and the hidden fault of hazard. And the last category of tile defect is joint defect, including joint detachment, joint discoloration, and joint cracks, which could arise from the poor quality of grout and not properly filled with grout. And the key impact of joint defect is aesthetic degradation, and the joint defect would also allow moisture infiltration and degrade the adhesion quality of tiles. And here comes the corresponding non-destructive testing method. The first one is impact acoustic. In the real case, labor would tap the tile with a small rigid object and analyze the reflected acoustic signal. And impact acoustic could be used to analyze could be used to detect the debonding tiles. And in current research, deep learning algorithms are used to analyze the acoustic signal and identify and detect the debonding tiles, reaching high accuracy. But there are two limitations of this method. The data collection is still manual based, which is inconvenient to deployment, inconvenient deploy when working at height. And the second limitation is the deep learning method could just only identify to tell the debonding exists or not. It can not identify the other physical information about the debonding, like barrel depth and size. And the second NDT method is infrared thermography, which captures the surface temperature of the tile facade, and the defective and intact areas could show the heat differently. And infrared thermography is quite suitable for rapid and large-scale detection of debonding areas, but it is relative low accuracy and costly because of infrared thermography is sensitive to the temperature and solar radiation. And also, infrared thermography is cost ineffective because the device is lean and expensive. Current research about infrared thermography to detect debonding is focusing on the influencing factors and implementation conditions. And there are only one research in our review is use the YOLO V5 to analyze the infrared image captured by the drones and identify the best flight areas. And third NDT method is image-based visual inspection, which capture digital images with cameras and smartphone and use deep learning models for analysis. This method is suitable to detect surface defect, fracture-related defect, detachment, and joint defect. Image-based visual inspection is suitable for rapid, large-scale detection, and it is cost-effective and convenient deployment. But in the current research, use this method to detect one single defect could reach high accuracy, but when classify multiple tile defects at the same time, the accuracy would decrease. And the last is ultrasonic testing. And this method could reach high accuracy of detection, but relative cost ineffective and inconvenient to deploy. And the research about ultrasonic testing to detect tile defect is really limited, with only a few attempts. And here's a brief discussion. The first is the comparative analysis of NDT method. And there is involving trends of non-destructive testing method adoption, changing from impact acoustic to infrared thermography and visual inspection combined with CV techniques for the faster, large scale, and more efficient detection. And ultrasonic and GPR, or namely ground penetrating radar, are powerful in principle but barely studied for exterior types. And the second is challenges of data acquisition. Now, in current research, the data about tile defect on building exteriors is still collected manually, and the data set about tile defect, publicly available data set about tile defect are scarce and lab collected. And in the future, we would like to improve the robotic platform for data collection and then construct a large-scale rebuilding data set. And finally, our review proposed a two-stage methodological framework of integrating non-destructive testing method for inspecting tile defect on the building exteriors. In the first stage, infrared camera and digital camera could be grounded-based or mount on the drums to realize large-scale and rapid screening the whole building and identify the potential defect areas. And in the stage 2, the climbing robot equipped with impactor or ultrasonic device or GPR could be sent to the potential defect areas and make a localized verification. However, this framework is still conceptual and it needs future validation. To conclude, the research effort is uneven. Adhesion failures are the most studied, while the joint defects are rarely addressed. And then the non-destructive testing method with different strengths and limitations. So we need to integrate multiple non-destructive testing methods to detect the tile defect at the same time. And third, deep learning could detect a single defect well, but multiple defect classification accuracy still needs improvement. And finally, a two-stage framework integrating different NDT methods is proposed. Thank you.
Thank you. Detecting method. How do you observe and define what do you start the parameters in your stage 1?
Actually,